Latitude Media, covering the new frontiers of the energy transition.
3 years ago, Zach Jones didn't have the best work environment.
I would walk into the office. Everybody was staring daggers at me. It felt like we were going to have a mutiny, like, a captain of an old-timey sailing ship and getting thrown overboard.
Zach is the co-founder and CEO of Graphitic Energy, a company making clean hydrogen and graphite in the same process. In 2022, the company had just spent 2 years and a third of its money designing a pilot plant that would crack natural gas into hydrogen and solid carbon using a molten system. Graphitic Energy was engineering the plant, working with contractors, and it was close to hitting the fabricate button. Everything was going to plan until the mutiny.
It got so bad that our VP of operations said, we need to have an offsite retreat for, the senior technical leaders and the senior business people to sit down and talk about this.
The this that Zach is talking about had come up at co-founder Eric McFarland's house.
Eric is a very creative guy and had the whole technical team over to his house for beer and pizza. And he said, just for fun, let's all just come bring our best idea and talk about different ways that we might go accomplish the same thing, extracting hydrogen from natural gas with no CO2 emissions. And out of that came an idea by our technical director of R&D, Sam Shaner, that solved all the challenges of this in a way that required no firsts from a balance of plant perspective.
But there was a problem. Sam's idea required using a completely different technology than the one Graphitic Energy had been developing for years. And Zach already had investors to answer to and a pilot plant to build. He couldn't abandon everything the company had been working on to chase a totally new idea. So Zach took a diplomatic approach.
I said, okay, that's cool. Let's file some IP on it.
Filing IP, or intellectual property, seemed like a reasonable compromise. The company could protect the new idea without derailing its current pilot project. But his team in Santa Barbara had different plans.
The next time that I came down to Santa Barbara, there was an experiment in the lab working on this. And I said, whoa, we have a whole list. And we've sort of developed as a company a prioritization scheme of what we're going to be working on in the lab because we need to be solving problems in the right order. So let's get back to working on the things that are relevant to the pilot that we're sort of building right now.
Zach thought he had reined things in until his next visit to the lab.
And then the next time I came down, the experiment had somehow gotten bigger. And I said, hey, this is supposed to be being wound down. Usually, reactor vessels don't increase in size when they're being wound down. And then I said, we're not spending any more company resources on this. This is an interesting idea, but we have to be building a pilot.
But even after Zach put his foot down, the technical team kept going. They started working on their idea on nights and weekends, arguing that they weren't spending company resources because they weren't on the clock.
I said, yeah, but you're in the company, you're in one of the fume hoods, so that doesn't really work. So absolutely no more, you guys have to stay focused. We've made the decision, we did the HAZOP for the reactor vessel, it's about to be fabricated. And the culture really went downhill for a while.
This is when that emergency retreat was called. Finally, away from the office, the lab, and the tension, the team was able to have an honest conversation about what they were really trying to accomplish. And Zach, who didn't want to spend more resources on any of this, realized that his team's new approach, it might actually be right. I'm Lara Pierpoint, and this is The Green Blueprint, a show about the architects of the clean energy economy. We've already invented most of the solutions needed to decarbonize the global economy, but many of those technologies are not yet commercial. They need to get financed and built at scale. We don't have decades to get them commercialized. We have years. This week, I talk with Zach Jones, co-founder and CEO of Graphitic Energy, about building a company that extracts hydrogen from natural gas without producing CO2, and it turns that carbon into valuable graphite instead.
In our worldview, in a perfect world, no one should be using natural gas via any other means except our process until we've exhausted all of our markets for solid carbon.
Today, nearly all hydrogen is made from natural gas through a process called steam methane reforming. But that process produces CO2 as a byproduct. Graphitic energy takes a different approach, methane pyrolysis.
So our process, instead of producing CO2, produces solid carbon that is an asset instead of a liability. CO2 is not good to be putting into the atmosphere. You can debate how bad it is, or maybe you think it's neutral, but it's not good. I don't think there's anybody on any spectrum anywhere saying, let's put more CO2 into the atmosphere. Whereas our carbon is always an asset.
The basic chemistry isn't new. Methane pyrolysis, which is cracking natural gas into hydrogen and solid carbon, has been around for decades. But there's always been one fundamental problem.
You flow methane over a bed of hot nickel catalyst. The reaction kinetics are fantastic. You make hydrogen, except the solid carbon coats up your catalyst, and then the reaction shuts down. You can regenerate the catalyst easily by burning off the carbon, by flowing oxygen through there. But now you've just made a whole bunch of CO2.
What makes Graphitic Energy's approach different is how it manages that carbon formation. The solid carbon that comes out of its process isn't just waste to be disposed of. It's actually valuable graphite powder that can be sold into existing markets.
So that's what our process does at a high level. We remove the carbon as a graphite powder. And for the markets that we have lined up for that, it's worth 20 times its BTU value. So 20 times the amount of money you'd get just for burning that carbon and making CO2 when we extract it as graphite.
But the crux of Graphitic's business isn't just making cleaner fuel and reducing emissions. It's doing it without the so-called green premium associated with fossil fuel alternatives.
The problem that we set out to solve 7 years ago now at this point is really to say, hey, I've got a pipeline full of natural gas. I've got a tanker full of CO2. How do I get the most hydrogen with the lowest direct emissions without using any other energy source aside from the chemical potential of that gas? And how do I do something with the carbon that eliminates the need for a green premium for this with respect to the cost associated with producing hydrogen today?
Thanks to the fracking boom in the US in the late 2000s, early 2010s, natural gas was cheap and abundant back in 2018. So Zach and his co-founder Eric McFarland made a bet that the market for their graphite powder would be profitable enough to make their company work.
Methane pyrolysis is only interesting if you have low-cost natural gas, which hasn't always been the case, and if you are concerned about CO2 emissions. And both of those factors really only started in about 2015 or so, once the fracking revolution took off, and it was clear that there was this huge abundance of natural gas, both in the United States and other parts of the world. People said, wow, we can really go underwrite to having gas at, $4 a million BTU or less long term. So it's those two factors that came into play.
Zach and Eric originally founded Graphitic Energy under the name C0. It wasn't until the end of 2024 that the company took its current name. But the overall mission of the company has remained the same since its inception. I talked with Zach about how he and Eric navigated the mutiny, how they kept employees and investors motivated and committed to Graphitic's mission, and ultimately how they got the pilot plant built and running. But first, we went back to that pivotal moment from the top of the show, the offsite retreat. Well, first of all, what happened at this team retreat? How did you kind of work through some of these challenges? And I think, honestly, telling folks, how do you communicate in moments like this of deep tension is really beneficial for folks to hear. But then where did you wind up going from there?
I think it was really helpful to get out of the office. And we did it overnight. We went and stayed at a little lodge up in the mountains of Santa Barbara, and we had a facilitator come in, and it was a full retreat. But it was really important to get people out of the office and to talk about the perspectives that everybody was coming from, because we'd had the technical team, hearing me, but not really hearing me about the expectations that our investors have for us. And, me hearing them on, this is not just another idea that we're filing IP on to go out and to go block in the space or file blocking IP or just cover all the bases, this really solves the core challenges. And around that same time, we brought on our now CTO, Patrick Hanks, who had spent 15 years leading novel process scale-up at Exxon. And so we were having him come out to interview, and the technical team said, well, I don't understand why we need this new leader. And there was, pushback just to the role itself, really. And then when they met Patrick, within a week, they said, this guy's amazing. We should have had this guy sooner. And so, I think there's a leadership component to it as well of, you need a strong technical leader who can go toe-to-toe with PhDs or has a PhD themselves to be able to explain, this is why we're solving problems in this order. And you don't need to worry about that until the second of a kind commercial unit. Like, we're worried about the pilot today and we're going to reduce risk in these three categories. And that's all we have to do.
So say more about how you identified Patrick, because it sounds like he had a really unique skill set that was both practical, but also that he could go as deep as he needed to with your chemistry PhDs.
So around the same time that we're sort of working on the new idea, evaluating that, the tension is growing, we're also interviewing candidates. And we had a fantastic recruiting firm that was honing in on what we really needed. There's a leadership component to it, but it's not really a operations component. It's more of a technical component. And when we interviewed with Patrick, it was just love at first sight across the entire management team, and then subsequently with the entire company as well.
Okay, and so once you brought him on board, tell me how the conversation went. Were you basically like, here's the approach we've spent all this money on and are ready to execute on. Here's the approach that the technical folks in the company want to pursue that solves problems. Pick one, or how did that work?
When Patrick flew out for his interview, he did all his interview prep based on the old approach. So, studying the fluid dynamics of bubble columns, being ready to not just look good himself, but also interview the startup company and say, am I going to go leave Exxon to go work for a startup company that's doing this? Like, is this technology going to work? And so he got to the office, and the first thing we did was give him a new presentation on, actually, we have a new idea, and we want your first sort of decision to be to help decide if the new idea is better than the old idea. And, he got it. It wasn't instant, but we obviously got him to join. So he was supportive of the idea. And he said, this is a really elegant solution to the core problem that exists in methane pyrolysis. So how do you get the heat in? So that was one of his very first things that we did with Patrick as a company was say, hey, this is a good idea worth pursuing. But we still had the pilot. So while all this was happening, we had to be building a pilot. And that was part of what we talked about at the retreat, which was we always have to be building a pilot. We've raised enough money and we've been at this, 2 years that we have to be pushing that forward because there are no points awarded for the best idea on a whiteboard. You got to build the pilot. So we overbuilt the pilot from a physical perspective, and we started with the utilities, and we had a pilot that could put the heat in a couple of different ways. And so we were able to go progress the design of the pilot in a way that allowed us to push off the decision about, what parts of this are we really going to focus on? And even today in the skid, we have areas that they've filled up with a lot of equipment that we've had to hack in and hack around. But you're sort of like, wow, there's like a quarter of that floor is just empty. And it's like, well, we weren't quite sure what was going to go there while we were building this whole thing. So we built ourselves a lot of flexibility in the pilot as well. And so with Patrick on board, we were able to, go through the analysis, hire the EPC firm to build the flow sheets to say, yes, this is what we can focus on here. And what we really need to pilot is the core reactor vessel that we call the carbon formation reactor.
So, this sounds like a super ideal solution that effectively what you're doing then is building the pilot in a way that it's flexible to both approaches. Did that involve a significant cost increase compared to what you were originally planning, or kind of what were the things that you had to do to make that possible?
It's been a little bit more expensive, and I think that as a result of that, there are parts of the pilot that are not designed the way that we would have originally designed them. So there's been a little bit of a trade-off there, but one of the things that we're really fortunate to have is that the pilot is at the Southwest Research Institute, which is able to do all sorts of on-site fabrication. Like the core reactor vessel was actually built on-site. So in order to go make changes to anything, we're able to go, have the welding crew come walk up and look at it, get the crane, take the reactor vessel off, take it back to the welding shop, make some tweaks to it, go back, set it back in the pilot, all with just the folks that they have on site there. So I think one of the things that really enabled that was the flexibility of Southwest.
That's very cool. Okay, so at this point, though, are you all in on the new approach?
We became all in on the new approach. It really took Technip Energies doing the initial FEL studies because the devil is in the details. It's not in the chemistry. We knew we could get the chemistry to work. And we knew that because it's really a fluidized bed, that we could get the fluid dynamics to work. It was a question of, can you build the flow sheet for this in a way that will make the resulting hydrogen and carbon economical? And so Technip completed their FEL1 studies of our technology at both the minimum efficient scale, which is about 6 tons of hydrogen a day, and also the maximum efficient scale, which is 270 tons of hydrogen a day, which is a world-scale hydrogen plant. They completed those. It looked good. And then they approached us and said, we want to invest in you guys and have a partnership because we think that this is going to be competitive with blue hydrogen, and in parts of the world is going to beat blue hydrogen hands down. And so that was certainly enough of a signal for me to be like, okay, all right, we have a good idea here. This is going to work. A company that does a third of the world's hydrogen projects wants to put some money into this. So that's a pretty big signal.
So Graphitic has officially decided to commit to using the new technology, but that doesn't spell the end of the challenges. In fact, it means a whole new set of them. More about that after the break. So once you're all in on this new approach that you're pursuing, and obviously Technip is as well, what were the things that changed with respect to particularly your products?
The big change was really around the carbon. And we as a company were slow to appreciate that. I mean, as we were running campaigns in the lab, obviously we're looking at the carbon, looking at the XRD and saying, wow, that's really graphitic. But the carbon that came from the previous approach was not. It was basically soot. And so all we had really ever thought about in the carbon was, how do we get our molten media back so we don't have to keep, replenishing that? And it really just was not in the company's DNA to think about that carbon as being a valuable co-product. And so around the time that we were finalizing the initial FEL work with Technip, our now CFO, but at that time VP of Finance, Steven Swager, who has a product development background, he had previously been the CFO of a carbon nanotube company, said, I don't think we should just assume that this carbon is going to go back into the ground and be a coal mine in reverse. We should get some samples out. So he sent some samples to his old company and then went out and recruited the former CTO of the biggest graphite producer in the United States to come be an advisor, and has been able to sort of really help develop that market on the carbon side. And when people think graphite, they usually think lithium-ion batteries, but they don't appreciate that there's a tremendous amount of volume below that very high-end application in terms of specifications. There's carbon that goes into the steelmaking process, into lubricants and refractories. And so Steven's really been instrumental in building out what we think is a 3 million ton a year total addressable market for our carbon in North America.
That's very cool. I think it's very cute, by the way, that you said most people think of lithium ion as like the market for graphite, when I'm like, that's those of us who are nerds who listen to this show. But I think the vast majority of people probably think pencils. So
Yeah.
just to calibrate us a little bit here. But this is really exciting. So how do you think now about the relative market size and sort of, ability of you all to capture market on the graphite side versus the hydrogen side? Where do you think the majority of your revenues are eventually going to come from?
The most important thing is to get the first of a kind built as quickly as possible, which means getting the carbon qualified with customers as quickly as possible. So we think that based on conversations we've had with specific customers, that we have demand for 300,000 tons a year as produced from our process, going directly into their processes and their customers' end uses downstream. First of a kind plant will produce about 45,000 tons a year. So we've got enough to build multiple copies of that just with the customer conversations that we have. The 3 million tons a year in North America would enable us to build multiple world scale plants. So, when that gets saturated, we're in the 2040s. And then the big picture vision is that, if you're willing to pay $3 a kilogram hydrogen, you can throw the carbon away. It's still, even without any carbon value, if you build a big plant, this is still, we think, the cheapest sort of non-SMR based hydrogen that you're going to be able to produce.
So at this point, as a company, you've discovered you've got this new sort of revenue stream, this whole other product that you can produce. You've got a really incredible hire, on the part of somebody who really knows what they're doing, building real things. You are ready to go and to execute and start building your pilot. So you've already mentioned a little bit about this, but say a bit more about kind of the main goals of the pilot. It sounds like at least one was to generate enough material that you could really get, customer proof points on the graphite side. What else were you trying to do, and how else were you thinking about the scope, like how much engineering scale up you were taking on with that particular pilot?
Yeah. So one of the things that was critical to have Patrick lead with the help of Technip was, how big should the pilot be? So my previous comment about, we're going to overbuild the pilot, that's just the skid. We just want to make sure that the steel structure has plenty of room to go fit all the different components into it. So it was really working with Patrick and Technip, and also an organization called the Particulate Science Research Institute that's kind of the leader in fluidized solids, to say the height of the carbon formation reactor, which is the core vessel, is really determined by the velocity that you need to send all these particles around on, and that's 40 feet, and we knew that from the lab. And then the diameter is based on, you need to really get to a foot in diameter with a fluidized bed before you get away from wall effects. So if you can get to a foot in diameter or larger, you can get away from wall effects and be very confident that you can take the data that comes out of that and scale it to whatever diameter that you want. And so one of the great things about our pilot, there are some not great things, and there have been some challenges too, but one of the great things is, despite that sort of initial flexibility that we built in, we feel really confident that that will give us all the scale-up data we need. It isn't we built this pilot because this is what we could kind of get done, and then we kind of have to go build a second one that goes and de-risks these other things. It should be apparent to anybody who looks at the full data set coming out of that says, yep, this is everything these guys need to learn about the fluidization dynamics to lock in and tweak the assumptions that we're making for the first-of-a-kind commercial project in the front-end loading studies.
And so as you're going in and starting to build this pilot, what are some of the initial challenges that you've encountered?
Initial challenges have all been balance of plant related. There are very few vendors that want to build pilot scale pieces of equipment. They're an order of magnitude bigger than things that are built for labs. They're an order of magnitude smaller than pieces of equipment that are built for refineries. So all the balance of plant stuff and I think this is true of any pilot, it's always an awkward scale. The heat exchanger or the compressor or whatever it is like a one-off, unique job. The companies that are making those for you know they're not going to go sell. It's not going to become a new product line for them. And so because everything's a little custom, everything has the tendency to have issues and be a little bit buggy. And so we've had pieces of equipment where we've rebuilt the thing almost twice over and and then the truck that was bringing the new flange got in an accident. And so we actually have had pieces of equipment that we didn't even get to break ourselves at the pilot that actually just broke trying to get to the pilot that we then had to go back and work on. And so I think that's what makes pilots so challenging is that it's a weird scale and everything's bespoke. And it's never been put together before in these configurations. But fortunately, it's all been related to the balance of plant. And every time we have a board meeting or talk to our investors, and they're like, "Okay, but what you guys are doing, that's working, right?" I'm like, yes, no, our carbon formation reactor is working. It's something else that don't worry, that's a solved TRL9 thing when we get to commercial scale, and that's actually critical to setting the minimum efficient scale for the technology is to make sure that when you go build the commercial plant, you're able to go get the off-the-shelf equipment.
Let's talk for a little bit about the financing side of this and particularly how you manage the investors. So for this pilot, you don't have customers per se, because part of the point is that you're making the graphite so that you can actually start, working with customers on providing them samples. You're flaring the hydrogen because there's not a ton of it that you're making, so it's not really worth trying to sell. So that probably means, I assume, that you're then funding this entire plant on your own balance sheet effectively with venture dollars. Is that what you all wound up doing?
There's contributions from Technip, but yes, effectively. That's right.
And so how did that work? How were you able to manage your investors around all of this, around a pretty big technological pivot that you made around, some of these things that you mentioned that include cost overruns? What was your secret to keeping everyone in lockstep with you?
Well, on the pivot part of this, I think we were transparent about the challenges as we incorporated them. But the real fundamental change is, how do you put the heat in? And so as we were going through this, flexibility within the pilot, the way that we talked about it was, and we've got a couple of different ways to go put the heat in, all of which need to be determined at pilot scale. And talking about that sort of flexibility and that ultimate down selection process, I think was helpful. We had to make some trips to Asia to go explain, hey, here's why the plan is changing a little bit, which is, it's culturally important to really, nobody likes it when the plan changes. But I think that talking about this as, hey, it's not like we're pivoting to say, oh, and guys, we're going to take the rest of your money and go mine Bitcoin with it. I mean, we're still solving the same challenge here, which is extracting hydrogen from natural gas without using electricity or making CO2. And so I think that was helpful, is that this is really sort of a different heat integration approach to doing the same thing that we were solving. On the budget front, we've had great groups of investors that have invested 2 or 3 times with us. I think because we've got a lot of corporates who understand that things take longer and cost more, and Breakthrough Energy Ventures has invested 3 times because they understand that they've got a lot of companies where they're working on something that is costing more. And so I think it's really a function of who's in your cap table, and do they have sympathy and understand that, doing a new technology in the real world is not always going to go according to plan. Sure.
Well, I imagine it's probably that, but also they must see something around the value proposition that you're bringing to the table, and something at the end of the rainbow that they remain committed to. So is that true? And how do you think about that and characterize it? And what do you think makes you all different? Like, why are they willing to stick with you?
I think it's having the right inputs and outputs to the process at a very high level. And the core prize of, hey, we're trying to get at hydrogen that is trapped in natural gas that costs 80 cents a kilogram. That core prize is still there. And that's why the company is still exciting to me, is that hasn't changed. Nobody thinks that's going to change. And so I think that communicating that and staying focused. I mean, within the spectrum of like, this is what we're trying to accomplish. And by the way, the carbon also has value here, and here's how we're going to go utilize that, has been really helpful to keep everybody sort of on the same team.
Yeah. Well, and I imagine at 80 cents a kilogram, you're really in a pretty incredible position to be competitive almost regardless of the market. But have any of your conversations gotten more difficult as the political landscape has shifted, I'll say, to put it mildly, in the United States?
I think that there's no doubt that there's maybe been a decline in hydrogen interest, but that's really almost entirely hydrogen from electrolysis. And so what we do is remind everybody that, hey, we use a fossil fuel, natural gas, to make a critical mineral, graphite, and that has the benefit of ameliorating the negative aspect of using natural gas, or the primary negative aspect, which is CO2 emissions. And so this is something that is a great idea thermodynamically and economically, because gas is going to be cheap for a long time in the United States, and everybody's on board with that. And if you can ameliorate the CO2 emissions in the form of making the carbon valuable, how is extracting natural gas any different than mining cobalt for batteries or some other sort of extractive type of process? So it isn't helpful that the rules are kind of changing all the time, but I think we've got a really good story about how we'll be able to get the first of a kind up and running and be able to build more of them.
You've done all of this work, and your pilot started operating last year. Is that right?
Yeah, it's up and running. We had to change out some more balance of plant stuff, but we're rocking and rolling right now. So that's really exciting.
That's awesome. Well, and then, of course, as a friend once said to me, the benefit of being wildly successful is that you have the privilege of going and solving the next problem. So for you all, it looks like a first of a kind actual commercial facility. So say about what your plans are. And I think one of the things I'm especially interested in knowing is, at what point did you really feel like you were getting started and making some serious decisions about that first commercial plant? Were there certain things you were waiting for with respect to results from the pilot? How did you think about the sequencing and where you're going next?
Yeah, I think we had to make the decision as a company that we were going to own and operate that first facility, because we had some LOIs on the licensing side. And we spent a lot of time having conversations about, well, somebody else is going to go build this. And we ultimately decided that we had to bite the bullet and say, somebody else is going to run into first of a kind issues and get scared if they even get that far. This is the company. This has to be us doing this. And so once we made that decision, then the commercial strategy became a lot easier, which is looking for hydrogen offtake. And because with our technology, you always want to locate it where you need the hydrogen. And then the solid carbon is trivial to move around. That's one of the value propositions. It's a lot easier to move around solid carbon than it is to move around CO2. And so, we recently hired an SVP of business development who spent 20 years in the licensing and then the project management space. And so, he's been out hunting down hydrogen offtake with blue chip customers who are blown away to see, like, wait a minute, this is a carbon intensity and this is what it costs? I thought that this was, I thought that decarbonized hydrogen had to come from an electrolyzer and cost, $6 or $9 a kilogram. You guys can do this for 2 to 3? Wow, that's incredible. So I think we've got a great pipeline of projects in the US and also a few opportunities in Asia. And I'm hopeful that the challenge is going to be taking the projects that we don't select and flipping those over to something that is, a pipeline to come online once the first of a kind starts up and runs. So we've got prospective opportunities in Texas, in the Midwest, and the East Coast. We're actually one in California, of all places. So it's exciting.
Okay, final question for you, Zach. If I could wire $100 million into Graphitic Energy's bank account tomorrow, what would you do with it?
I think I'd use it to catch our breaths a little bit and kind of say, let's bring the pilot down. Let's go make some changes here. All the things that we've got duct tape and baling wire on, let's go work on those. I mean, I know our team would love that, to say, oh, we're going to spend a year just sort of fixing things and making improvements there, that would be great, and then come back up. So I don't know what I'd do with the other 90 million, but that's what I would use the first 10 million for.
That's amazing. That's an incredible start. And I especially love the zen in your answer. I feel like all startups deserve that. They deserve some moments to take a breath. And I really wish that our funding environment allowed for that more often. Okay, Zach, this was absolutely amazing. Thank you so much for taking the time to speak with me today.
You bet. Great to be here. Appreciate the time, Lara.
Zach Jones is the co-founder and CEO of Graphitic Energy. The Green Blueprint is produced by Latitude Media in partnership with Trellis Climate. The show is hosted by me, Lara Pierpoint. Our producer is Aaron Hardick. Ann Bailey is our senior editor. Sean Marquand is our technical director. Stephen Lacey is our executive editor. If you'd like to suggest topics or guests for the show, send an email to thegreenblueprint@latitudemedia.com. You can listen to The Green Blueprint at latitudemedia.com or subscribe wherever you get podcasts. And if you have fellow clean energy or climate tech travelers who would benefit from insights in the show, send them a link. This is The Green Blueprint, a show about the architects of the clean energy economy.